Hello everyone, in this video we'll be solving problem 129, sum root 2 leaf numbers. The problem statement is we are given the root of a binary tree containing digits from 0 to 9 only. We need to return the total sum of all root 2 leaf numbers. The value of the path between the root node and the leaf node is to include or concatenate all of the node values in the path. For example, from the root node 1 to the leaf node 2, there are only two nodes in there. If you concatenate the value, the path sum will be 12. Similarly, if we look at the right leg, the value of that path will be 13, 1 and 3. Adding the two paths gives us the output 25. If you are not familiar with the leaf node, a leaf node is a node with no children. In this problem, we need to start traversing from the root node and identify all of the leaf node that we can go to by using DFS. And as we are traversing through all of the nodes, we need to maintain the value at each node. Let's switch to whiteboard and discuss how we can solve this. Let's use this as an example. The best way to solve this problem is to use a DFS based traversal or depth first search, where we try to traverse through the binary tree until we stumble upon a leaf node. In this example, we have a total of 3 leaf nodes. So we need to build path for 3 between root to these individual leaf nodes, build the value, and then at the end add it to the common sum, which will be returned as the output. If you look at the leftmost leg, at node 3, the value will be 1, 3 or 1, 3. And if we go even deeper, the value will be 132 because we appended 2 to the collection. We'll repeat the same operation for other leaf nodes. If we are at node 4, the corresponding value will be 134. And for node 7, it will be 157. Once we have identified all of the leaf nodes and completed the traversal, all we need to do is add these values and return the sum. The time complexity of this solution is O of n, where n is the number of nodes in the given binary tree. And the space complexity is O of 1, that is constant space, because we are only using this one variable to maintain the sum of all of the paths between the root and the leaf node. Let me show you how we can implement the very same solution using C#. Here is my C# solution. In the main method, I am calling this helper method DFS traversal, passing the root node and the current sum. This current sum will be updated as we traverse and go deeper into the binary tree. In the DFS traversal method, I am first checking if the node is null. If yes, then we can return 0. If no, then I am building the value of the current sum by including the node.value. It is the value of the node that the current pointer is pointing. After that, I am checking if the current node is a leaf node, that is the left and the right node are null. If yes, then we can return the current sum as is. And if no, then we recursively call the DFS traversal method, passing the left and the right node recursively, sum their return values, and return it as part of the method's output. Once all of the recursive loops are complete from the DFS traversal method, it will return the final output, which is being returned from the main method as well. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 76% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.